Welcome to today's Statistics and Probability lecture. Today we're going to look at how to use contingency tables to solve problems of conditional probability. In this example, we're going to use contingency tables to solve conditional probability problems. Let's begin by reviewing the formula for conditional probability. And that's the probability of B given A equals the probability of A and B divided by the probability of A. And if you recall, the probability of A and B is the intersection of the two probabilities. So let's solve our first problem. The first problem says find the probability of depression given they are overweight. So that means we want the probability that someone is depressed given that they are overweight. So with contingency tables, I'm going to start with the denominator. The denominator is going to be the probability of being overweight. So let's put this right here. So we're looking for the probability of the intersection of depressed and the intersection of overweight divided by the probability of overweight. So we're going to do the denominator first. So I'm first going to look for my overweight category because that's my denominator. And because I want the probability of overweight, I want to find all of the participants that met that criteria. So that's going to be this right here. So I'm going to put 135 as my denominator. That's the probability of participants that were overweight. The next thing I want is I want to look at, to find the intersection between depressed and overweight. So I've already got my overweight participants, and now I want to look at my depressed participants. And what I'm looking for is where is the intersection between depressed and overweight. And I see that it's right here at 85. That's where the yellow and the green crosses. So that's my intersection, and I'm going to put that right here at the top. So 85 divided by 135 is going to be my solution. And when I do that calculation, that gives me 0.6296, which means there is a 62.96% probability that if my participant is overweight, then they are also likely, they have a 62.96% probability that they will also be depressed. So let's do this same thing with our next question. The next question says, find the probability of being overweight given that they are depressed. So this is asking for just the reverse probability. We want the probability that someone is going to be overweight given that they've identified as being depressed. So that is the probability of overweight intersecting the probability of depressed. all divided by the probability of being depressed. So I'm going to want to find my denominator first. So I'm looking for the depressed participants, and I want to get all of the depressed. The probability of all of the depressed participants, so that is going to be 160. And that's going to be my denominator, probability of depressed. Now I'm going to look for the overweight participants, and I'm going to be looking for that intersection. The intersection where the two colors cross, once again, it's going to be 85. So that's going to be on my numerator. And then when I do my calculation, 85 divided by 160 is going to be 0.53125, which means that I'm going to have a 53.13% probability that if someone has identified themselves as depressed, they are also going to, I have a 53.13% probability that they are also going to be overweight. So you'll notice that on these two diagrams, we were both dealing with overweight and depression, the probability of overweight and depression, but we were reversing our conditions, and so that also reversed the order and gave us slightly different numbers. Let's do two more examples with these same contingency tables. So the next question says, find the probability of depression given they are not overweight. So we are looking for the probability of depression, a probability that they are depressed given that they are not overweight. So once again, our numerator is going to be the intersection of depressed and not overweight, divided by the probability of not overweight. Okay. And let's see what that is. So first I am going to look for the probability of not overweight. So that is this right here. And we want, this is our denominator, the probability, so we want the total number of participants who are not overweight. And that's going to be 100. And then for our numerator, we want the intersection between depressed and not overweight. So that's going to be where these two colors meet, and that's going to be 75. So that is 0.75, which tells me I have a 75% probability that if someone is not overweight, they are 75% likely that they will also be depressed. Let's do our next problem. The next problem gives us the probability of, find the probability of not being overweight given that they are not depressed. So that is going to be the intersection of the probability of not overweight and not depressed. All divided by the probability of not depressed. So once again, I'm going to do the denominator first, and I'm going to look for all of the people who have identified as not being depressed. And so that total, the total number of participants that said they weren't depressed is going to be 75. Then I'm going to find the number of participants that identified as being not overweight, and I'm going to be looking for the intersection of where the not depressed and not overweight so that gives me 25 divided by 75, which is 0.3333, which is 33.33%. So that tells me if someone identifies as not being depressed, there is a 33.33%. They will also identify as not being overweight. I hope you have found this tutorial helpful. See the links below for additional supports and resources, and be sure to like and subscribe to get the latest videos by Caz Academy. I'll see you at the next video. Thanks for watching.